So just observe here, observe here. So now how to derive the topic? It's a very simple derivation based on the moment of couple definition. So how moment of couple is defined? Now the moment of couple, just see here, I am writing the equation for moment of couple which you already learnt in mechanics. Whenever equal and opposite forces, that is couple of forces are acting, how much is the moment of couple? Now this moment of couple by definition, actually you have derived this moment of couple using simple vector laws. You have actually derived this. So based on the derivation, actually one simple equation comes. So what is that equation? Moment of couple is proved to be equal to the product of any one force in the couple of forces. So any one force in the couple of forces multiplied, product means multiplication, product of force and the perpendicular distance between the lines of action of the two forces. So force into perpendicular distance between the lines of action of two forces. So between the lines of action, just observe here. So lines of action of that is between perpendicular distance between the lines of action of the two forces. So lines of action is difficult to write because it's very lengthy. That's why it's called as simply perpendicular distance between the two forces. So but perpendicular distance between the two forces here is nothing but perpendicular distance between the lines of action of the two forces. So what is the line of action of the two forces? Easily it can be seen here. Now just see the first force acting on the positive charge, it's upwards. So it's acting along this line this way. So this is the line of action of the first force QE. Second force can be taken as minus QE. So what is the line of action of this force? This way, downwards along this line. So now you draw a perpendicular from this line. So I can actually extend it backwards. So we'll get the complete line. But that's actually not required for this. This is sufficient. This downward direction of the line of force is sufficient. Now you draw a perpendicular from one line of action of the force to the other line of action of the force. The perpendicular will be like this. Very simple. This way. This is the perpendicular. So the negative charge is usually called, it's denoted by symbol S, and the positive charge is denoted by symbol N. Actually, S and N stands for South Pole and North Pole of a bar magnet. S and N actually really stand for, so I'll write N more clearly here. This is N. So N stands for North Pole and S stands for really South Pole. So it is proved that a negative charge really behaves like a South Pole. Exact, not behaves, it is exactly similar to South Pole of a bar magnet. And positive charge is exactly similar to the North Pole of a bar magnet. That's why the same symbols are actually, it's better to use here. So some textbooks follow the symbols S and N. Other textbooks follow other symbols actually. Say A, B like that. Any symbols can be, doesn't matter. Why S and N are used here? Because negative charge behaves exactly similar to South Pole of a bar magnet and positive charge behaves exactly similar to North Pole. This actually comes more clearly later in another lesson called as magnetism. So magnetism is actually the third lesson of the entire electricity. Electricity consists of different lessons. Already we have seen earlier. First lesson is static electricity, next current electricity, next magnetism. So magnetism is just nothing but extension of current electricity related to very important properties of moving charges. So next is electromagnetism. It's a combination of electricity and magnetism. Next, electromagnetic induction. It's actually the reverse of electromagnetism, electromagnetic induction. And next continuation lessons like alternating currents, next electromagnetic waves, etc. So these are the various lessons of electricity. So now coming back to the topic. So when we are drawing a perpendicular from one line of action of one force to the other force, this perpendicular you call it as say M. So or SM you call the perpendicular. Perpendicular means this angle is 90 degrees. So we have a right angle triangle now S and M. So what is the perpendicular distance between the lines of action of the two forces? SM. So that can be used here in this equation. So force into perpendicular distance between the two forces or lines of action of the two forces. So this is the equation for moment of couple. Now just observe here. So we are writing only the equation for magnitude of the moment of couple. So direction means both magnitude and direction must be there, will be there for a vector quantity like the moment of couple. So bar is used. But always in equations, the bar is actually avoided. The reason is a vector equation, when left hand side is shown as a bar, right hand side also should be shown as a bar. So this right hand side we are getting only magnitude. So to show that it's a vector, we have to multiply it with a unit vector. So all that becomes complicated. That's why vector equations are avoided in derivations unless it is compulsory. Most of the situations vector equations are avoided. So that's why bar is actually missing here. So even here also you see the force QE. So that bar we are avoiding. The reason is this equation is easy to remember only in scalar form. QE, force is equal to F is equal to QE, though it's a real vector. Where E bar, E is a real vector, so force F is also a vector. F bar is equal to QE bar. So scalar form, it's much more easier to remember. So now again, coming back here, so C is equal to force into perpendicular distance between the two forces. So what is the force here? Force acting on, so each of the two forces in a couple of forces. Only magnitude must be taken here. Magnitude of force in the couple of forces, each force in the couple of forces. That's the meaning here. Any one force into perpendicular distance between the two forces. One force is what? QE here. So perpendicular distance between the two forces is what here? SM is the perpendicular distance. That's what we are getting from the diagram. So next is here SM can be actually expressed in terms of known lengths here. One very important known length here is nothing but SM is actually we are getting from construction. It's the perpendicular distance between the lines of action of the forces. This can be really expressed in terms of standard length here in the diagram. So what is the standard length here? Length of the dipole. So this total length of the dipole SN, it's nothing but what? 2L. We already seen length of the dipole. So in terms of 2L this can be expressed provided any one angle is known here. But just see here, these are parallel lines. Just see here, this is the direction of the electric field. Just observe here, this is the direction of the electric field and this is the direction of the force QE, which is also in the direction of the electric field. So these two lines, this line, observe the cursor here, this line and this line are parallel lines, and this line, which is nothing but a part of the dipole, is the transversal. So always for parallel lines, two parallel lines and the transversal, alternate interior angles are equal. This angle and this angle are really what? Alternate interior angles. So this theta means this also will be theta. Just see here once again, this line is parallel to this line and this line, observe the cursor, this is the transversal. So these two are alternate interior angles, always they are equal. So this angle is theta, already we know, we have seen, we have taken this one. This is the angle between the field and the dipole. Dipole is inclined with the field at an angle theta. So this is theta means this also is theta. Now use the trigonometrical ratio involving this side and this side. So this side is what? Opposite to theta. And this side is what? Opposite to 90 degrees. That means this side is hypotenuse. So opposite side and hypotenuse, which is the trigonometric ratio, sine theta. So use the equation for sine theta. So based on, so here Q into SM it's coming. So here now using sine theta. So here sine theta is equal to what? Opposite side divided by hypotenuse. So it is SM divided by hypotenuse. What is hypotenuse? Length of the dipole, 2L. So from this SM will be what? So SM is simply equal to 2L, take to the left hand side, 2L sine theta. That's what we are getting. So I'll just make a small adjustment here. I'll just remove the border line here so that some little space is obtained. So from this SM is equal to 2L sine theta we are getting. So this is a very important relation which we got. The constructed perpendicular distance, we are getting it in terms of the known fixed length of the dipole 2L and the angle of inclination theta. So substituting that here, QE into 2L sine theta, it can be written. So just see here, this is a rough column, a very simple example of a regular couple. So rough column, always steps are very important. They are the reasoning steps of the actual derivation. They explain the entire derivation very clearly. So always they must be taken compulsorily. This is the eye, the position of the eye, which is seeing the top, the particular situation from the top. This is the top view of the rotation of the tap. So now substituting this here once again, just see here QE into SM, in place of SM 2L sin theta. So it will be QE into 2L sin theta. So QE into, I'm writing the same thing, just see here QE into 2L sin theta. What is this here? the moment of couple. Moment of couple is this much. So now 2L you write along with Q, 2L into Q, and next write E into sin theta. So what is the reason? 2L into Q, length of the dipole and charge on each side of the dipole is what? Dipole moment. So the product of length of the dipole and the charge on each side of a dipole is nothing but dipole moment, electric dipole moment. So substituting that here in place of 2LQ, P can be substituted. So therefore what we are getting is C is equal to PE sin theta. So just observe here. Now just observe here. P is the electric dipole moment. It's a vector. E is the electric field vector. It's also a vector. C is also the moment of couple. It's also a vector. So really left hand side we have a vector. Right hand side also we have the product of the magnitudes of the two vectors and sine of the angle theta between them. Now already have learnt about cross product of two vectors. If you have two vectors, just again we are using a rough column, you see, reasoning steps. So rough column actually I'm using on the left hand side of this particular page. Actually right rough column I should be drawing on the right hand side. But already left hand side space is already used for the previous rough column. So I'm using the same continuation rough column here. So what is the cross product of two vectors? Cross product of two vectors is a vector whose magnitude is equal to what? Magnitude of a vector is denoted as what? Modulus. It's a vector whose magnitude is equal to product of the magnitudes of the two vectors and the sine of the angle theta between them. So P sin theta really is the magnitude of the cross product of two vectors P bar and E bar. So the magnitude of the moment of couple is really nothing but what? Coming to be equal to the magnitude of the cross product of two vectors P bar and E bar. But what is the direction of P bar cross E bar? So you have learnt that from the right hand thumb rule or right hand screw rule. You have learned that the cross product of these two vectors P bar cross E bar, it is exactly perpendicular to the plane containing P bar and E bar. So what is the plane containing P bar and E bar? P bar and E bar, it's nothing but the horizontal, this horizontal plane of the blackboard itself or whiteboard itself. So this horizontal plane, it's nothing but we have taken as ground, because only on the ground north, south, east, west directions are actually shown. So P bar cross E bar, it's a vector perpendicular to the plane containing P bar. P bar is in the horizontal plane, E bar also is in the horizontal. Perpendicular to the plane means it is in the vertical direction. It's perpendicular to the horizontal plane, it's a vertical direction. But that direction is actually given by the right hand screw rule. What is right hand screw rule? We have to put a right handed screw perpendicular to the plane containing P bar and E bar. That means in this plane. And we have to rotate the screw in such a way that in a direction from first vector to the second vector. From first vector is this, second vector is this. So from this to this, in this direction we have to rotate, putting the screw perpendicular to this plane. So perpendicular to this plane means it will be out of the whiteboard. It will be out of the whiteboard. So above this, it's a point. It will be pointed directly to the sky, because assuming this as a horizontal plane or a horizontal tabletop, directly the screw will be directed upwards towards the sky. So you are watching this on the screen means it will be directed towards you. That way the screw is placed. So only the screw head will be visible. This is the screw head. Only that screw head will be visible here. That way. And then you have to turn it in this direction from the first vector P bar to E bar this way. So imagine the screw here placed here. Only the head will be visible. The complete length will be behind the head. That way it's placed. So when you're turning it in this direction, in what direction the screw advances? It will be advancing outwards, out of the plane of the whiteboard, out of this horizontal plane in which the diagram is actually considered. That means it will be rotating in such a, it will be advancing towards the sky. In that direction, the cross product of two vectors is present. So now, what is the direction of the torque? Now the torque direction, we have seen that it's anti-clockwise. See here, the torque direction is anti-clockwise. Now, whenever torque is a real physical quantity, it's a vector quantity. Its natural direction is anti-clockwise. Its natural direction is anti-clockwise here. Only two possible directions will be there for torque or moment of couple, either anti-clockwise or clockwise. But a mathematical, because it's a vector quantities, very simple vectors like force, velocity, displacement. All of them have their own single line directions, arrow directions. So for torque also an arrow direction is selected for convenience because it's a real vector obeying parallelogram law of vector additions. Only few quantities having both magnitude and direction obey parallelogram law of vector additions. Only they are real vectors. For example, you have learnt velocity. It's a real vector. It obeys parallelogram law of vector addition. It has magnitude and direction. But what about velocity of light? Velocity of light also has its own magnitude and direction. Direction in which light moves is the direction of velocity of light. But still, velocity of light from theory of relativity, it is found that it does not obey parallelogram law of vector addition. That's why velocity of light is not a vector quantity. Every velocity, every other velocity is a vector quantity. But velocity of light is not a vector quantity. So the moment of couple is found to a vector quantity, but its natural direction, physical direction is anti-clockwise or clockwise. But just like any other vector, it's also given a line direction, arrow direction. In what direction it's taken, again that's also obtained from the right hand screw rule. You have learned this. The natural or arrow direction or the vector direction of a moment of couple or torque due to couple, it's obtained from right hand thumb. The same way you have to put the right hand screw in such a way that exactly perpendicular to the plane of rotation. It's rotating in what plane? In the horizontal plane, the dipole is actually rotating. So perpendicular to this horizontal plane, you have to put it exactly as earlier. So head will be placed here. I have drawn it separately outside for convenience. So and then we have to rotate it exactly in the direction of the actual direction, anti-clockwise direction here, or the moment of couple. Then in what direction the screw advances? Again it advances up perpendicular to the horizontal plane. That is, it will be advancing skywards towards us in the plane of the whiteboard, perpendicular plane of the whiteboard. It will be advancing towards us. So that's exactly in the direction of p bar cross c bar. So c bar is a vector in the direction of p bar cross c bar, and magnitude of c bar is p sin theta, same as the magnitude of p bar cross c bar. That means they are equal vectors. So that way in vector notation, c bar can be c bar, p bar and e bar are related this way. So vectorially, the expression for moment of couple is c bar is equal to p bar cross c bar, and magnitude relation is what? C is equal to p sin theta. But more useful is the magnitude only. This magnitude expression showing the magnitudes of the three quantities: moment of couple, the dipole moment p. Just I'm using the same pointer just here, cursor. The moment of couple C magnitude, the electric dipole moment P magnitude, and the electric field E magnitude. So this is the relation between the magnitudes along with the sine of the angle theta between the two vectors P bar and E bar. So this is taken as the final expression, and this itself is very important equation. And in vector notation, this can also be written as like this. So this is not difficult to remember vector notation because AB sin theta is A cross B, P sin theta is P cross E. So both are very useful equation. So this is called as the main result 1, and this is 1 dash. It's not much different. Only the difference is vector notation, but it's less useful. So it's not difficult to remember the other equation also. So I'm just putting this as say 2.5 stars. It has less applications. This equation has very wide applications. So this is about the simple derivation. So now quickly running notes should be completed. Now the thing is, I'll just this is a very important simple rough diagram of the rotation of the head of the screw. So I'm just putting it here in the rough column because it's only useful for understanding. Any doubt comes, the right hand screw rule will be helpful. So whatever things we have seen are very simple, nowhere any complications there. Now quickly complete the running notes. Just see here, entire derivation is as it is. Very simple. How many steps are there just in the derivation? You see, this is the simple basic equation for moment of couple, force into perpendicular distance between the two forces. Next substitution here in the diagram. Next bringing sin theta into the equation. In the very almost next 1.5 steps, we got the answer. See here. So main steps, you see, only two main steps are there. The definition of the moment of couple, the defining equation. This is called defining equation for the moment of couple, and then substituting the perpendicular distance sm in terms of sin theta. This is the second step. And next, almost in the next step, we are getting the answer. This is simplifying only, just simplification, the same thing. Sin theta bringing into the equation and then using this other step. So three steps, that is moment, that is dipole moment P is equal to LQ is used here, and directly we are getting, just in main three steps we are getting this. Very simple derivation. So now quickly complete the running notes. So an electric dipole Sn of dipole moment. So compulsorily you have to write the running notes as I am saying it. So I am writing on the board also, but very fast I am writing, it can't be understood later. So now itself it should be written. So not much, only 3 or that already I said it's carrying 5 marks. Any essay question throughout all the universities of the, that is all the colleges of the entire world, essay questions maximum they carry only, not just even in not just the 11th and 12th classes, even in higher classes when you go for a degree like a science engineering degree or science degree or even still higher degrees like PG, essay questions nowadays throughout the world carry maximum 5 marks only, not even 8 marks, because even an essay question of 8 marks also, two parts will be there, a bit and b bit. The first bit is the real essay question carrying 5 marks, second bit is a small problem 2 marks to 3 marks, a 2 marks problem and one definition will be given. So 5 marks, 5 marks means as less as possible. Just see here, 5 marks already we have seen it's covered here. So about 2 marks for the diagram, or even 1.5 marks there also, 1 mark for this. So 1.5 plus 1 how much? 2.5. So remaining 2.5 marks for the simplification here, including the very important equation dipole moment is equal to LQ. So just 1.5 marks for this. So totally 5 marks. So it's very simple, not much explanation. So language explanation, regular explanation, paragraph, it should be as small as possible, maximum 3 to 4 lines, not more than that. Full explanation is not required. See here, we have used many facts, north south direction, east west direction in the horizontal plane. All that explanation should be avoided. It's a real life situation, so it's very clear in the rough column. So this is also rough. See, any doubt comes, what will help us is only the rough column, real life situation, because everything scientific has been observed from real life situations by different scientists. So they have followed that way, we also have to follow this same way. See here, the right hand screw rule, all these details should not be explained, as short as possible should be written. Just see here, only 4 or 5 lines I will be writing here. After that directly the derivation starts, no other explanation. We'll be getting the answer, final answer, 1 and 1 dash, that's all, very simple to write. So and so now itself you are any always when you are preparing for entrance examinations, the board syllabus only is followed. So you should be revising the scientific derivations. Scientific derivations are there only in the board syllabus. So in the entrance examination only problems will be useful. So every problem is based on a scientific derivation itself, or a formula, or the definition. They only will be helping. So always you should be revising the scientific derivations. They only will be really helpful in solving any kind of problems. So that derivation you should be writing as simple as possible. That you should be doing while preparing for the board exam itself. When you are listening to a topic, what you are going to write in the exam, in the board exam, you should be deciding within 5 minutes, then and there itself. So listening to the derivation in the class, writing the notes later is not proper. Immediately within 5 minutes you should be completed, like a running notes. But while listening, you should be avoiding writing. So immediately after listening, within 5 minutes you complete it. That's why I'm giving the running notes now itself. Now itself you have to complete it now. So electric dipole Sn of dipole moment P. So more clearly it's P bar. So in the derivation we are taking only magnitude P only, but for accuracy it's P bar is placed in a uniform electric field E bar at an angle theta as shown. So next another small line should be written. The two charges experience equal and opposite forces plus QE and minus QE. What is this equal and opposite forces called as? That is a couple. So this is a very simple line but very important. So next, so therefore, so moment of couple equation we are using, that's all. That's the simple explanation. Just see here, just two paras. First para, it's actually, though it's actually appearing as some 5 lines, I am using only half of the page, half left, one third left of the page. So the page only less than half, you see, half of the width of the page I am using. That means one third of the width only I am using. So this is really only 2 lines and this is 1 line. So immediately after that, therefore moment of couple C is equal to force into perpendicular distance between the two forces. After that, this sine theta is equal to Sm by 2L. So just see here, as it is, it should be taken down up to here. So here, but what is P? Dipole moment. So that should be written clearly. So but, so I'll just move the equation a little to the right. So that sufficient space is right there for writing dipole moment. So but, so dipole moment. So here I have written very quickly. The word is not clear. Just remember this because already still you did not write the earlier part of the note. Just remember this. But dipole moment P is equal to LQ. So this is the basic equation. So therefore C is equal to P sin theta. So now vectorially. So vectorially, that means in vector notation. This is the equation for moment of couple. So its direction is, what is the direction of the moment of couple? Its direction is perpendicular to the plane containing P bar and E bar. That's all. So this is the completion of the derivation, main derivation. So after this, actually 2 points are there, very simple points. So it can be seen that points can be easily guessed here. So moment of couple is proportional to sin theta. So when sin theta is maximum, moment of couple also will be maximum. When sin theta is minimum, moment of couple also is minimum. Those are the 2 points. So but it will take at least 5 to 10 minutes. Actually time is over now. So we'll stop the class quickly. So now you have to complete the running notes. Compulsorily take all the rough column points, including the rotation of the head of the screw. So this head of the screw must be imagined here at this position. You are rotating it in a direction from the vector P bar. This is the direction of vector P bar to this is the vector E bar. So that's the thing. Any doubt comes, the rough column steps must be used. Each and every doubt can be very easily clarified. It can be very easily understood. We can get the answer very easily from the scientific examples. Scientific examples are not special examples, they are regular real life examples. So this is the completion of the main derivation. Almost 99% is completed. Remaining 1% is sin theta maximum value, sin theta minimum value gives maximum value of couple and minimum value of the couple or moment of couple. That's all. So this is the derivation. Now quickly complete the notes within 5 minutes before going to the further next class.